Hello viewers and welcome to a new STM32 World Tutorial video. Now in this video we are going back having a look at my earlier videos regarding SD cards. I am going to go through creating my own SD card breakout board and well, follow me along and I'll explain. I'll not design it from scratch, but rather go through it in detail here. So let's see what this is all about. Now, as I mentioned, I made some videos earlier about SD cards using SDIO and using SPI. Now, I'm not going to go through the details right now about these two, but SDIO is basically 4 data pins, whereas SPI, you only have 2, data in and data out, and a clock signal. So it's a few more lines, and it is quite a lot faster. So it is interesting to use SDIO if at all possible. Yeah, those were those videos. Now, in all those videos, well, I did have a board where I actually had an SD card on it. But for most of the videos, I used my own adapter, which I made with one of those mini SD, I think they're called mini SD adapters, where I soldered some jumper leads on. And I didn't talk much more about that, except I just used this one. Now, what I didn't mention in the video, I think I forgot, but they were not easy to make because that plastic melts really quick when you're trying to solder on. I think I tried to make 4, and I think out of those 4, 1 was working. So I wouldn't recommend this approach at all, but it is possible. I had this working, and it is working. So why didn't I buy breakout boards? Surely they're available and surely they are cheap. Well, let's have a look at that. Let's look at let's look at micro SD breakout on AliExpress, and the first one that pops up here, well, it's pretty clear that is actually SPI, and it's got a level converter, so presumably 5 volt. Presumably this is meant to work with Arduino. It even Adafruit, a 5 volt breakout board. So this is meant for 5 volt, and it is only SPI. It is not SDIO. Here's another one, which that one was $4. Here's one you can buy for 76 cents, and it actually looks like it's got all the data pins out, so this one would be an option, but it doesn't have the pull-up resistors, so it still wouldn't work as it's supposed to work, because it doesn't have the pull-up. Pull-up resistors are necessary on all the data lines and the command line, not the clock line, but all the other lines. So, and look at the back. There are no pull-up resistors on this card. So while it's cheap, less than $1, it is not very good. Let's see a few of the other. No, I can't be bothered. I've been through all of them, and they are not readily available. It's possible that you could find one. I will not rule that out, but most of the ones that are available are SPI, not SDIO. And they are mostly made for Arduino, meaning they have some kind of level shifter between the 5 volt Arduino and the 3.3 volt SDIO card. But more importantly, they are all SPI. And the one I managed to find, which is the one up here, that actually have all the data signals out, is not doesn't have the pull-up resistor. Now you can make it work with the internal pull-up resistors. That is what I did with this card, but that only works with very, very short wire. If you have slightly longer wires, this will not work at all. If you have watched my last couple of videos, you will see that I actually made a deal with JLCPCB that they were willing to sponsor some boards for me. And without going into too much detail about that, one of the things when I order from JLCPCB is that the shipping typically become a relatively big part of the total bill. But JLCPCB offer the feature of actually combining multiple orders into one order, so you pay one shipping, but you can have 4 orders in that shipping. So I decided to do an SD card breakout to include in that first order, just to well, basically fill some stuff up on it. So let me talk you through the SD card breakout board that I made, and let's start by looking at the schematics here. Now, it is a very, very, very simple schematic. It's got a header with a power, VCC, and ground, and the data, the 4 data 0, 1, 2, and 3, command, clock, and SD card detect pin as well. There is a couple of decoupling capacitors here, and there is a number of pull-up resistors for every line except the clock line, which is not pulled anywhere. And then you have the card over here. Laid out on a PCB, it becomes really quite small. It is 30 millimeter times 24 millimeter on the widest part, and 1.16 millimeters on the shortest part. Now the layout is very simple. It is just a relatively fat power line. Ground is on the as a ground fill on both sides of the board, so ground return should not be a problem. There's no wire down here. It's the whole backplane is wire. The whole PCB is ground, and then you have short, thinner wires, which just brings the signal up, but at the pull-up resistors. And if we look at a 3D rendering of this board, it will look like this. 2 capacitors up here, the 6 resistors, and the holder for the SD card, and on the back side there is a pretty detailed. Of course, this board can be used in both SDIO and SPI mode, and I have verified that as well. A little trick here for people who want to order with the JLCPCB: if you put somewhere on the cell screen JLC, 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 JLC in caps, that will be replaced by the board serial number once they produce it, and that way you can control. If you don't put that in, they will just JLCPCB will just put it somewhere, and you cannot control it. But if you put this in, you can control where that label is placed. So now I made this, let me talk you through the ordering process. First of all, oh, we don't need that anymore. So let's go to JLCPCB. And I want to sign in just to see what this comes. Let's say we want to make 10 of these. 10 of these breakout boards and see what that will cost us. So I log in to JLCPCB. I select order now. I have to upload the Gerber files. Now that was in, hang on, source SD breakout PCB. Now I had revision D, I went through a few, and I have zipped all the Gerber files into an SD_D zip, and let's try to upload that file to JLCPCB. Takes a short while. So there you go. You can see this was the top side with the components. This is the bottom side. Let's increase this order to 10, just for fun. That does increase the price a little lower here for the PCB, but that's okay. Let's do that. Now, let's make it thinner. 1.2 millimeter was what I sort of expected to use. Default is 1.6 millimeter. We could give it a different color. Our order is still only on $5.20 for 10, that's 50 cents each. We have one option we need to select down here, and that is mark on PCB. They will need an order number, but we can put the order number specify position. That was a JLC, 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 and that will put it in. Let's I normally use FedEx actually. So let's have a complete order price. So at the moment we are about $15, so $1.50 each board. But let's put some components on. So we enable the assembly. We select which side we want to assemble on, and that is, of course, in our case, the top side. We want economic and we want top side mounting, and that is about all we need here. We don't need any of the advanced options down here. They are the one where it starts cost something. So let's look at this. So there we have the PCB as it is going to look. I tend to pay attention to details when JLCPCB goes through these pages. One thing, I managed to put this order in first time without the drill file, so all these were green. None of the holes were there. So this is a good place to verify that everything looks reasonable before we continue. And now you need a bill of material file. So let's start with the bill of material. We are at DBOM. That is a comma separated file. It has been mentioned in an earlier video, or was it the live stream, where I go through the whole ordering process of a board I just designed. So you can go and look at that. And a position file, which is there. So now we have uploaded the bill of material and the positioning file, process those two, and see what happens. There we go. Now, let's start by the unmatched components. That is my pin header. I'm going to solder that on manually, so never mind the pin header. But the other components, there was the two capacitors. They find it. The 10 microfarad cost 5 cents and the 100 nanofarad cost 2 cents. And then there is the card connector. That is the expensive one. It is about 80 cents a pop. There's 10 of them. Less than $1 each. And the resistors, which for 60 resistors cost 5 cents. That's how cheap resistors are. Anyway, I'm quite happy with this, so let's click next. Now, it is saying that I have unselected parts. Well, that's my jumper, so I can live without. Do that. Do not place. And here we go. I'll drag that up to the center and zoom in. So the SD card holder looks perfectly okay, and the location of the capacitors and the resistors look perfectly okay. Nothing in the header, which is what we expected. So let's onward and upward, and let's look at the entire order price. Is $27 for 10 of these boards. 5 for the PCB, $22 for all the components and the placement. There's a setup fee of $8. Now, if you click in the link below on this file, there's a link to, they will give you a coupon that pretty much take the setup fee away completely. I think it's a $9 coupon. There might be, if the first time you use it, there might even be a sign-up bonus, which you can use to pretty much make this order extremely cheap. I haven't gone through the numbers, but you'll see that they charge $1.50 to make a stencil. They charge the $50, $65 for the components, and that was mostly, as you remember, it was mostly the SD card holder. Now there's an extended component fee. Now JLCPCB have what they call basic parts and extended parts, and the basic parts are free. That's resistors and capacitors and stuff like that. But the SD card holder is an extended component. That means there is a setup fee of $3 per component. But it doesn't matter how many PCBs you make, you only pay that setup fee once per order. So that's fine. And then they charge you 50 cents to assemble. And there is nitrogen reflow soldering, which costs $1. I have no idea what that is. If you know, please describe in the comments below. And that is about it. Now I need to select what it is. I'll say this is definitely a development board of sorts, and save to cart. And that is it. $27 for 10 of these boards. I'm not going to order it now because by the magic of YouTube and video capture, where are we? Here. I have it here. Here we have, I don't know if I hope you can see that. I don't know. The holder is there, and over on the other side you have, you have the pin header. I've not soldered it into this board. I don't think I have one line here where they're actually soldered in. But as you can see, it is not very big, and it is, shall I say so myself, designed how an SD breakout board. Now this, would it work with Arduino? I don't know, to be honest. Arduino, many Arduinos run 5 volt. I don't know, and I don't care much about. So never mind that. Probably not. Maybe not. But it definitely works in this one, and this one should be with STM32 MCUs. So that's about it. Let me go away again there, and let's go back to this one. No, this page where we have these videos. Now, if we are starting to look at, let me fire up, by the way, let me fire up STM32 Cube ID, which I just yesterday upgraded to 1.19. Just to be clear about that. I have not seen any box yet, so I think that is the one I'll be using from now on. It was released, I think, yesterday. Here we go. Now, if we look at the original video, the first one I did in 33 was SDIO, SD card, and FATFS. And if we look at the source code in the STM32 fun repository, which is on GitHub, if I remember, it'll be linked down below. You can see it there. But there should be an STM32 World SDIO, SD, FATFS, and here it is. Now let's have a look at the Cube MX setup of this board. As usual, after you start Cube ID first time, it takes a bit of time. There we are. I managed to load the Cube MX, and let's look at how it is configured. We have the interesting part is we have the SDIO enabled down here in SD 4-bit wide mode, and if we look at the actual connections, we have them up here. We have the command, the clock, the S3, S2, the SD detect, and down here we have data 1 and data 0, and that is essentially it. Now, if we look at the let's have a look at the video. Where are we? We can do it like this. Here we can see the device hooked up. The breakout board is down there and it's hooked up with the wires to one of my STM32 World extension boards and on the now this is not very elegant, but it will work. It's and it actually, as you can see, these jumper leads are actually 20 centimeters. That was the only ones I could find. That was male, female right now. So, well, it will have to do. So let's go back here and have try to run it. And as usual, down here we have a serial output, and you can see it shows the SD card information, and it writes in 680 milliseconds. Sorry, it's very quick, and then it reads in 1 megabyte of data. It reads in 300 milliseconds. It will read 1 megabyte. That is the fastest I've ever managed to run with the SDIO. So this, in conclusion, there we go. In conclusion, this device works absolutely perfect, this breakout board. So now you've seen the ordering process. If you are curious to try this with JLCPCB, it will be linked below, but go to GitHub. In my personal GitHub, LB Thompson, there should be the SD breakout. Where are we? Repositories. Here we go. And you can see in PCB, you will have the ordering files. So essentially the files you need to order this board from JLCPCB will be down here. You will have the SDDC. That is, let me just confirm. So I need some stronger glasses to read this. The one I have here is revision D. So yes, you have it here, down here. You have SDD, zip, and the BOM and the POS files. These three files, which have a weird description, but that is ready to order. They're here. DD, ready to order finally, I think. I would be surprised if I didn't actually put a tag on it. I normally do tags. I forgot that for D, so yeah, okay. But the latest revision of this will work file, and the files are in the PCB folder. So if you want to try this, and I mean, I came up to, was it $27 for 10? You can probably get this for, I don't know, $15 or so. For 5 of them, you can make 5 and have them shipped, and then you can have your own little SD card breakout board. You can also, which is what I would recommend if you're doing this, I wouldn't recommend you take my files. I recommend that you clone this repository and play around with it in KiCAD. And well, if you can put your own name on it, I don't care much about that, and then you can try to order it yourself. All the part numbers are there, all the everything you need, and as you can see down here, it is still running and it works beautifully. It reads and writes at full SDIO speed. Let me just show you that in the. It is at the moment running with you have it here, SDIO clock divider of 2. So that is the 84 megahertz. You need to get down below 50 megahertz to make this work. This is 84 divided by 2, so it'll be 42 megahertz I'm running at. And it's kind of the highest I can make this work with these clock counts here. So a clock divider of 2 should be Actually, yeah, I'm thinking, will it work with one? It should actually work with one because that is true, right? It's always one lower than what we want to. So let's try to generate. I'm just trying. I have not tried this. This may go horribly wrong. And it is definitely pushing it a little bit. But let's see if we can make this work with. Because I'm actually dividing by 3, I think. If I set the. Let's see. I should not sit here and guess. I should go in and actually read the goddamn data sheet, but I haven't. So I'm guessing I'm just fine. There we go. I can still read the card, and it was faster than it was before. What was it? Before 346 milliseconds. And now it's 294 milliseconds. So I'm definitely running at 42 megahertz clock on 4 data lines, and that is about as quick as this, and it is still beautifully supported with 20 centimeter jumper leads to this board with some fairly heavy pull-up resistors, I gotta say. So yes, so that is about all I wanted to check today. Let me repeat my thank you. I mean, this is not advertising for JLCPCB as such, but they already always treated me nicely, and they were very helpful, and they always done a good job. So I would strongly suggest you try them if you're interested in making some PCB, and they are helping my channel to make some interesting breakout boards and devices. More will come later, which helps keeping this channel interesting, I hope. I might have bored you to death today, I do not know, but I hope not. As usual, like and subscribe is always appreciated. Links are down in the description. There will be links to JLCPCB where they will give you a coupon, or 3 coupons, I think it is. And there will be linked to the repository on Github, and there will be linked to the page on the STM32 wiki. So please like and subscribe, check those links out, and I love receiving comments, so please comment in the comment field below. And that's about it. As usual, have a wonderful rest of the day.